So after PowerPack session on API security, we have Yusuf with us. He's the security tech leader at the Middle East region at the IBM, and he's going to talk about the API security in open banking context. Because open banking challenges we have already learned how to overcome it, how to overcome the open banking challenges, and the API security, have to maintain the API security in the open banking context is one of the really important aspect. So we have the Yusuf. Hey
Yeah, hi
Yusuf.
Shreya. Hi.
Hey, hi. Thank you very much for joining. And yeah, stage is all yours.
Yeah, thanks Shreya for having me in this API Days conference. It's a pleasure to have here and talk something about API security in context of open banking. Although I have just 20 minutes to speak, so I will just quickly go through the main subject. I'm just going to share my screen now. I hope it is already visible, but just making it full now. All right. Okay, so I'll start with directly with the security context because throughout the day we are talking a lot about open banking and audience well know very well about what we are talking about and how it is actually disrupting the market, especially in the when we are talking about digital transformation and opening the new products and services which can fulfill the requirements for better digital experience for the customer in terms of financial services, fintech services, banking APIs, and banking services. So I'll just quickly show this map, which will show actually like how it is throughout the world. It has been proliferated, and what we know today, open banking is coming in three flavors, where one of them is obviously the country-wise or region-wise. People are going for a regulation and writing or regulations which need to be followed by the respective entities as well as the implementers. And the other one is especially about the European region, which we are showing it here in dark blue. Actually, whatever in dark blue, it is something PSD2, and that is something more prevalent in European region. Light blue is something the regulatories which are approach which has been taken by the country at the individual country level, and the yellow one are those which are especially market driven approach to the open banking, and they are like still emerging and working on the regulations or the regulatory bodies. Uh, Now I'll take a typical example. I mean, I'll not go into very complex detail, but this is a very straightforward way how it's a very simple use case or very prominent use case in terms of open banking. And when we talk about the traditional banking, the actors are less, if you see. And once you open it up in terms of open banking, you see more actors. And when there are more actors, there are more chances of having risk and threats associated with each actors and the entry points. So in typical example here, if you see a user which will be interacting, who will be interacting with the third party app. Let's say, for example, this user wants to do some payments through a mobile app, which is going to use some of the services of the bank, which is where the user is having an account. And obviously, in order to prove or complete the transaction or maybe use the services, user has to prove their identity. So for that purpose, definitely there is another actor, which is the identity server. It could be an internal or external or a federated identity server, which will be used for proving the identity of the user. Third-party apps could be anything. It could be any mobile app or its own bank app, or maybe some other partners or service provider, which will be providing services on top of the bank. And obviously, at the end of the corner is banks or the financial institution or any resource server which will be opening up opening up these APIs. So this is the API layer. So here, if we talk about this very peculiar scenario, most of the time uh, today, most of the API is being protected by token-based approaches. And when we talk about token-based, specifically OAuth or OpenID Connect comes in mind. And most of the implementers are very much compliant with the OAuth or OIDC based protocols, which will be a quick startup, or which can be quickly integrated with any third-party identity provider or any other compliant identity servers. So here, as I said, there are different actors, different risk factors, and different way of securing all those aspects. Starting with the user, because none of the APIs which you will be exposing for this bank system will be non-user agnostic. That means there is always a user needs to be there to access those API with a proper authentication or session in place. None of the APIs can be used, should be invoked directly by the client app itself, which will be fetching any banking services related to the user. So since user is one of the key, you can see one of the focal point here. So two main aspect about the user which we have to protect is about strong identity authentication of this user, as well as from the user's point of view. It's very important to maintain the privacy as well as the consent while using those services through the third party apps. Moving on to the second actor, which could be a third party app or any other app which will be interacting for open APIs. So here it is very important to make sure that these clients or apps are authenticated securely or communicating securely, to invoke those APIs or consume those APIs. Then from the bank point of view, it's very important to make sure that the requests coming in or the APIs which are being accessed through these channels are having the proper security measures, and um, they have a way to make sure that the token presented, because most of the API, as I said, are token based. The token presented are authorized, authenticated, and checked with the party who has actually issued them. So it's very crucial. As I said, the bank needs to authorize or verify those tokens, and also the origin of those tokens, to make sure that the token being verified or so called as introspected is actually issued by the same identity server. And finally, we talk about identity server. Yes, there need to be a trust, to make sure that the identity provider which are trusted can only issue the tokens, and that can be only presented to access those APIs. And finally, those can be introspectable by the actual consumer of the service, to make sure that this is going to happen. So if you can see, there is an ecosystem which is working on a trust based ecosystem, and those trusts are actually being checked at each and every point. So in order to check those points, we have to put, this is required to put some security controls or additional controls. I'll go back to the same thing which I said, that most of the APIs, or the way API is being protected using the token based mechanism, and that's why OAuth or OIDC is one of the basis of having those API securities. I'll introduce something called as FAPI or SIBA. I'm not sure in the previous session if it has been already being talked upon, but if I start talking about a very high level about what is FAPI and how actually it is going to provide the security layer, is again, as I said, the OAuth2 and OIDC are the main protocols which are being used for interacting with the identity provider and consuming the APIs. So FAPI is, you can say, a technical specification which is built on top of these two profiles. When I say these two profiles, obviously it comes into your mind that it is the client application, identity server, and the resource server, which is actually hosting the APIs. How these are interacting, and the way they were interacting. I'm going a little bit technical in this slide. So those who are already aware about OAuth or OIDC protocol, they already know that there are certain grant types, or the way the client authenticate themselves to get the token, as well as to authenticate user and present authenticated user, preliminary code to get the access token. So what FAPI has done, it has introduced some more additional security controls, which are going to provide higher security, higher security for the APIs, which needs to be exposed through these channels. So that's why it is called as financial grade API. So it is very much similar to exactly all the concepts and entities which are being used in Auth2 and YDC. And some of the things which are added on top of it, maybe we can talk about it. There is a history about it. Maybe I'll just quickly skip on it. But talking about the FAPI profiles, it is mainly segregated in two parts throughout the, if you see the history timeline, it is finally having the FAPI 1 version, which is already in implementation phase by many implementer. FAPI 2 is still an active draft, which is being worked upon to have to work on the more improvement. So as I said, FAPI profile is basically coming in two flavor, baseline and advanced. So quickly cover it up. Baseline is mainly for creating a kind of a baseline for those APIs, the security controls, so that those APIs can be accessed by imposing those particular security controls. Baseline was mainly initiated for, let's say, kind of read-only APIs. This was something termed by FAPI community itself. And advanced is something which is having more read and write, or you can say the APIs which are not only fetching the account details, but also doing some kind of a transaction initiation, transaction approval, or maybe dealing with the adding or deleting of the beneficiaries. So these two flavors comes up, and I'll just maybe touch upon very quickly upon these profiles. So before just going to that, because we have talked about SIBA also. So just to touch upon SIBA, that why SIBA was introduced, because there are certain scenarios. This is a very typical scenario you'll find on the FAPI website, which demonstrate that there are certain scenarios, especially in the most of the smart devices nowadays, which are interacting with the end user to do certain actions or provide certain services through the service providers. One of them is like you are talking to a smart speaker to get a service, which will be talking to the end system to make sure that you are the authorized person, and then provide that service. So in such cases, most of the time you don't have anything to interact with the you can say something called a consumption device, or the device which is the consumer, which is consuming the service. So here the end user is having its own device. This is another device. This could be another device, and then you are trying to interact and get a service. So in such cases, most of the time you don't have the way to interact in just like you do in browsers. So that's why it was introduced, where the client can initiate a backend channel authentication request, and then once the request is placed, it will send out of band, or you can say in a decoupled manner, the request to the other smart device or authentication device of the user to get the authentication approval. Once it is received, it will complete the OAuth cycle, where you will be issuing the access token, and then the access token can be used to access those APIs or services. To a very high level, there are many other use cases which can be used later on. Like, for example, traditionally, when you are dealing with uh, a bank agent on call, and agent wants to verify your identity before giving some services or initiating some services, and you both are disconnected completely, and instead of using traditional knowledge-based authentication, asking user details about date of birth and other things, or sending some OTP, which can be still prone to phishing or other SMS phishing attacks. So in such cases also, this protocol comes handy, where you can use it and create a client initiated backchannel authentication, where the user can authenticate on the other authorized device, which is already identified by the systems and pre-registered with the system, and you can do the complete the authentication. It comes in three flavors. I'll not go in details. Maybe I'll just quickly go through the next slide. But at a high level, there are different ways to obtain the token, where the backend channel can keep on polling until the user completes the authentication. This is called as poll. Ping, where once the authentication is completed, the identity server will ping the backend system that the authentication is completed, and then backend will retry to get the access token. Finally, the push mechanism is where once the user approves or completes the authentication, the identity server or authorization server directly sends the access token to the backend system without asking backend system to retry or reinitiate an API to get the access token. I'll go to the next slide. This slide is a bit technical, but I'll try to cover at a very high level, and it answers that why FAPI or FAPI or CBA is important. And there are some major security, controls have been imposed, or you can say being provided under this specification, which needs to be followed once your product or once your system is FAPI compliant. You need to make sure that these security controls are in place, and then you have at least the security which is providing more security than the traditional API securities. So I'll touch upon the major security risk, which why FAPI is important and how it is being covered. As I said in the beginning, there was a diagram which I showed, which has clearly four main actors: client app, user, actual resource server, which is bank or any financial institution, and identity server. So this specification, especially focuses on making sure that the trust is being maintained and the security controls are put in order to make sure that any actor interacting with the other actor has been trusted with the authentication or the credentials being required for the security control of that transaction. So when we talk about client app or the third party app, we want to make sure that the client is interacting with the resource server or identity server in a secure fashion. And that's why if you see in the traditional OAuth or OIDC, you have client credentials where you have client ID and secret to prove your application authenticity. That means once if you want to prove the authenticity of your application, you need to present client ID and secret, which can be called from any other place, and the resource server or identity server will not be knowing that whether it is the same person, it is the same app, or the credentials are being stolen. So we have the FAPI has added another security layer which says that the client should be secured with more controls, which one of them is, these two are there: client secret JWT and private key JWT, where it says that in order to authenticate the client, you need to the identity server needs to ask clients to do a signature of their JWT or sign the JWT, which is signed either using the client secret or using the private key, which is already being exchanged between the identity server and the client app. Then it also asks to go for a mutual TLS. Mutual TLS is not a new concept. It was already in place, where you want to make sure both client and server are verifying each other in terms of their in terms of their HTTPS certificate or SSL certificates. And this handshake happens by having those certificates pre-exchange or having a publicly trusted certificates. So that's so in FAPI, it builds something on top of it, where it provides a way where you can impose the TLS client auth for the endpoints of identity server to make sure that the client is actually the one which is already in the trusted list of identity server. It could be either a pre-shared key pair or a public trusted key pair, or a self-signed, as I said, or a self-signed. So in order to make sure that the client who is invoking the API to get the token is actually in the trusted list of identity server or the authorization server already. Then there are some token leakage scenarios, which we know that once the access token is being obtained, once it is hijacked or leaked, it can be used to invoke the APIs, because the APIs are most of the time non-agnostic of token origin, because once the token is presented, they are just serving based on the token validity. So FAPI has introduced something called a certificate bound access token, where it makes sure that the tokens which are presented to the resource server or the backend system which is going to provide the service, or the API management layer, which is going to handle this API. So it makes sure that the token which is being presented is actually requested by the same client, and it has not been taken away in between to and being called from some other system or some other device. So for that, it has introduced something called as it always sends once you issue the token from the token endpoint, it will give you the hash of the SSL certificate, as well as once you do the introspection, it will also return the same certificate. So once you are being presented with such tokens, it is mandated in FAPI to go and introspect such tokens and validate if the certificate is still bound with those access tokens from the origin of the token issuance and the origin of the API invocation. Okay. Um, Other thing which also covers at a very high level in FAPI is to protect the request parameters in the browser in the URL, because if you see normally in traditional OAuth request, it is exposing many parameters in the request, like ACR values or some other scope values, which are being exposed to the whoever is a malicious actor in the or anyone who wants to get the details, more details about the request and scope parameters. They can also play around and try to um, try to get something out of it. So in order to protect that, OAuth has already written a specification called as pushed authorization request. FAPI mandates, not mandate, it recommends to use PAR for at least advanced profile API invocations. So this is also taken care, and then it also advocates about handling the IDP mix-up for malicious IDS actors. Here, this actually makes sure that when you are interacting with the identity server, make sure that this identity server is the same, which which is trusted, and not somebody or not someone malicious or the fake identity provider which is proxying your request to the actual and taking care of and taking your credentials or using the code or access tokens. So in order to protect that, there are some security controls which are being placed, which can take care of to make sure that the code and the state, they are also attached and signed by the JWT issued by the identity server. Finally, he also talks about the non-repudiation, where ID token is used as a detached signature. Detached signature where the actual content and the signature are actually not in the same packet. So here the requester knows the parameter which are being presented while taking the token, and then once the token is issued, it has the signature of all those parameters, where the requester can actually validate that it is actually coming from the intended identity server. So these are like some high level. As I said, this slide is a bit technical. Maybe one can get in more details of getting samples as well as sample Postman request to see how it is actually happening. Um, so
Okay.
yes, sure.
Okay, Yusuf. Yeah. I think we are running out of time. And thank you very much for sharing about the API security and everything.